Number 5. Show that these 3 points in three-dimensional space are collinear, so they lie in the same straight line. A, B and C I'll put down, whichever way you happen to be looking at that in space. Well, to show they're collinear, you have to show that you keep going in the same direction. Whatever direction you're heading in going from A to B, you have to keep going the same way to C, or else you'd be off at an angle. So work out the directions of them. So what are the components of this directed line segment? Well, you could just read them straight off, but they'll probably want you to do subtract the position vectors. But I'm not going to do that for the segment because I'm only meant to be doing this quickly. So we've got B, 6, -1, 5. A, -3, 2, -1. Add the 3, 9, -3. Add the 1, 6. So that's quite nice because you've got multiples of 3 there. Now what about B to C? What direction is it heading in? We do the same, C minus B, but I'm just going to put it straight down. 6 to 12 is 6. -1 to 3 is actually going back 2. 5 to 9 is going forward 4. And from that you can see that AB is always, or rather the components of AB are always the same multiple of BC. They're all 3 over 2 times it. So since that's the case, that means that AB is parallel to BC. Means they're going in the same direction, because that doesn't mean they're joined up, just because you're heading the same way. You have to have something in common, and since B is common, or a common point, or whatever you want to write, it means it must be joined up. You've gone along and you've stayed in the same place and you've carried on for the other one. That means that A, B and C are collinear. Right, that was that first part. And it was the first part, wasn't it? Yes, that was A. Now there's a B. There's only one, and you just have to state it because you've already worked out. You've got the multiple here. You've got 3 upon 2 times it. So that must be 3 steps to 2 steps. Because that's what it cancels down to. 9 steps to 6 steps cancel down to 3 to 2. That says 3 to 2, etc., etc. So what's the one? What's the ratio in which B divides it? Well, AB to BC is equal to 3 to 2. Number 6, there we go, wave equation. Express this in this form. Now, I know it says A, but it's just easier to write an alpha than it is to write an A. And it's not going to appear anywhere else anyway once you've got your answer. For 4 marks, radians, set the calculator to radians. Well, first of all, we'll expand that to try and make it look like this. So cos will go to cos the first, cos the second, minus sine the first, sine the second. Now that would do, but I prefer to take out the coefficient of cos x explicitly. So it's k cos x, alpha, multiplying the cos x, don't need to of course, minus k sine alpha, well, it's really an A, I know, sine x. And then you can compare them term by term. So that means that the cos has got 5 in front, so k cos alpha must be 5. K cos alpha equals 5. And the sine has got k sine in front. I just put it on top because of the cos. And it's negative, so that will equal a 9. Right, so you've got 2 equations and 2 variables here. If you square and add them, you'll end up with k squared equals 9 squared plus 5 squared. So k will be the square root of that. It's the square root of 81 plus 25, which is 106. So odd one that. And if you do, if I've got room, well I'll do it, I'll just do it here. If you do equation 1 divided by 2, should have done it over there, you'll get tan alpha is 9 upon 5. And then you'll get an answer of 1.0636 and so on. And I'm going to keep it as 3 decimal places here, 1.064 then for alpha. Now it doesn't really matter what alpha is because I'm going to finish it off by saying this. So now I've got 5 cos x plus 9 sin x is k root 106 cos of x plus 1.064. There we go, look, 106, 106. In part B it says, hence solve, and it just keeps it the way it is. 5 cos x minus 9 sin x equals 7. Well, that means that root 106 cos x plus 1.064 is equal to 7. So that means that cos x plus 1.064 is equal to 7 over the square root of 106. So x plus 1.064 will be inverse cos of 7 over root 106. But this time there will be 2 answers. So we're probably going to use this here then. So the cosine's positive, so it's going to be either here or here. So it's just a case of finding what that acute angle is in radians. And when you press the buttons, you've got 0.8231 and so on, which means my answers will be x plus 1.064 will be either what it says, 0.823, or it will be 2 pi minus it, 0.823. Now straight away you can see that's going to subtract, that's going to go negative, and that's outside of the range of 0 to 2 pi. So what you can do is you can go forward a whole wavelength and add 2 pi onto both of those. So there is another one, which would be this added on to 2 pi. 2 pi plus 0.823, because it goes on and on forever, doesn't it? Which means in this case, I'm not going to bother with that one, because I know in advance you can work it out and then it turns out negative and you have to discard it anyway. But I know in advance when I take that across, that's going to be no use. So these are the 2 I want. So I'll just put in what they are first of all. So the first one is 5.460. The next one is 7.106. Final answer. Just take that away from each of them. So I think I'll just, instead of rewriting, I'll just subtract them. So that one would have been 6.042, and that one's 4.396. And there it is. It's quite a lengthy question calculation wise.